Hello dear friends, before the start of this video, we want to say there are 100 of us. Thank you very much for your support. There's much more to come. Two things are infinite, the universe and human stupidity, and I'm not sure about the universe, Albert Einstein. Hello dear friends. In today's video, we would like to tell you about the concept of the multiverse. It is becoming increasingly prevalent in popular culture. For instance, it drives the plot of the popular TV show Rick and Morty and the fourth phase of the Marvel Cinematic Universe. In this video, you will learn about the scientific hypothesis of the multiverse and how it might be structured. Before we begin, we would like to ask you to subscribe to our channel. Your support will greatly aid our development and the improvement of video quality. Now relax and let's begin. The emergence of the multiverse concept. According to the hypothesis, the universe we inhabit might not be the only one in existence. In reality, there could be an infinite number of universes, all interconnected within the multiverse. This concept might seem a bit far-fetched, but if it holds true, there exists an alternative world precisely resembling the one we live in. The hypothesis gained serious attention after scientists measured the cosmological constant in 1998. This parameter was initially introduced by Einstein while working on the theory of general relativity, and more than a century ago, it seemed artificial. However, American astrophysicists Saul Perlmutter and Adam Ries measured the cosmological constant with understanding that it accounts for the expansion of the universe. For their work, they were awarded the Nobel Prize in Physics in 2011. When astrophysicists measured the cosmological constant, an intriguing discovery emerged. The theoretical predictions for this constant deviated from the experiment by 120 orders of magnitude, making it the worst prediction in modern physics. If it were zero, as Einstein initially thought, it could be explained. If the constant were significantly large, that too could be easier to explain. Yet it's both small and non-zero, and the reason remains unclear. To account for the value of this constant, the hypothesis of multiple universes emerged, reinvigorating this question. One version of the multiverse hypothesis can be formulated as follows. There exists a multitude of universes, each with its own value for the cosmological constant. Among these universes, one precisely matches the observed value in our own universe. How the multiverse could have formed. The concept of the multiverse pertains to several fields of physics, but it is most closely associated with the theory of inflation. We discussed this in our video about the Big Bang, which you can watch by clicking on the link in the top right corner. Imagine the universe in its infancy, a fraction of a second old. This is where the theory of inflation comes into play. Inflation suggests that the universe underwent an exponential expansion, magnitudes larger than what we see today, and from this explosive growth emerged the potential for multiple universes. According to the chaotic inflation theory, it didn't happen just once and end, but continues and evolves in different regions of space. Under certain assumptions within this theory, the possibility arises for the existence of universes within the multiverse with different elementary particles and their interaction laws. In other words, the scenario of chaotic inflation aligns with the concept of the multiverse, where new universes emerge as a result of eternal inflation. To understand this process, you can imagine a universe undergoing vigorous growth processes similar to boiling water. Excess energy leads to bubbling, fluctuations in space-time, ultimately forming bubbles, new universes. If these bubbles are small, they quickly collapse, releasing energy that gives birth to new worlds. However, if the bubbles universes are robust, they grow, becoming larger and expanding, at least until they also burst. When this happens, the energy from this process also leads to the formation of new universes. This is referred to as the bubble hypothesis of the universe. It echoes the Big Bang theory from which the universe's expansion began, but the Big Bang we know is not the only one, just one of many. Furthermore, the multiverse hypothesis suggests that inflation doesn't occur uniformly everywhere. Individual universes can borrow from other expanding universes, giving rise to an infinite number of new ones. In this scenario, each universe arises with its own laws of physics, particle compositions, force arrangements, and fundamental constant values. This may explain why our universe exhibits certain concepts that are difficult to explain using fundamental physics, such as the cosmological constant or dark matter. Many scientists strive to find compelling physical evidence for the existence of the multiverse. If our universe once had a neighbor, it could have collided with it, leaving a detectable imprint. For example, He-Ling Deng, a cosmologist from Arizona State University and an expert on the multiverse hypothesis, continues attempts to prove the existence of parallel worlds by searching for unique types of black hole. Scientist believes these could be artifacts of parts of the universe that emerged through splitting into ours, and a parallel one through quantum tunneling. However, there are facts that contradict existing theories. In his latest work, physicist Stephen Hawking, in collaboration with Belgian colleague Thomas Hertog, stated that the model of infinite inflation is incorrect, as Einstein's laws of general relativity break down at the quantum level, becoming useless. According to the renowned scientist, the cosmos isn't infinite. Everything has clear boundaries, sizes, and structure. In this work, Hawking asserts that there may be several universes, but they all resemble each other. According to the Hawking-Hertog theory, if parallel worlds exist, the laws of physics in them must be the same as in our universe. Ultimately, there is a possibility that somewhere there is an exact copy of you watching an exact copy of this video. And since there is an infinite number of universes, according to the Institute of Physics, there will be an infinite number of exact scenarios occurring simultaneously. Even to the edge of our universe is a vast distance, and there is no hope that we will ever reach it. Moreover, all universes have boundaries. People might think about them differently, but most likely those are not the boundaries we can cross. That's why whether the concept of the multiverse is true or not will likely remain one of those unanswered questions, at least in this universe. Thank you very much for watching. If you enjoyed this video, please don't forget to like it. If you're as intrigued by the mysteries of the multiverse as we are, don't forget to hit that subscribe button. Join us and stay tuned for upcoming videos where we explore even more cosmic wonders. Leave your comments below about what you would like to see in our next video. Thank you, and see you next time.